Hey guys, it's Hank. Seems like one of the hot topics of today is mind control. And I guess it stems from, why is everybody acting so strangely? Why are people doing things against their best interests? Why are they following systems that benefit only a few and not themselves? And what is the blindness? What are the mechanisms of control? Who is the man behind the curtain? And so many people have gone off into, V2K technology, which I can get into later, alpha state programming, binaural frequencies, stuff like that. We can talk about that later. But yesterday I made a video called Why Hasn't the Stock Market Crashed? And in that I talked about financial engineering. And I'm going to, in this video, lay out some definitions so you can kind of start to see how mind control has existed for a very long time using a variety of different methods. And it's not just hypnosis, it's not just a framework or somebody beaming a message into your head or harp or anything like that. It's actually far more simple. Humans are machines just like anything else, and they can be programmed. So let's talk about financial engineering and how that relates to other types of terms, mechanical terms, so it makes sense about how things are engineered. So, in any system, you've got an energy system. And the energy system breaks down into three separate categories: potential energy, kinetic energy, and dissipation. Now, in physical mechanics, good coffee. In physical mechanics, potential energy is referred to as elasticity or stiffness. And bear with me, all this will make sense. It'll all come together. And an example of potential energy in a physically mechanical process is a stretched spring. When the spring is released, when the string is stretched, energy is stored, and when it contracts, energy is released. Thus, there's the potential energy in the stretched spring. Kinetic energy, defined through physical mechanical terms, would be inertia or mass. Kinetic energy being the movement. And an example of inertial kinetic energy in a physical mechanical property sense would be a flywheel in motion that you see in various types of machines, cars, tractors, combines. If you don't know what a flywheel, all you guys probably know what a flywheel is, so I won't belabor the point. But that's what inertia and mass, the kinetic energy of the physical mechanical property. Okay. Now the third property in physical mechanics that has to do with the energy system is dissipation. The dissipation of energy. And in physical mechanics, this is generally done through friction or resistance. So an example would be a dashpot, which essentially is mechanical energy being transformed into heat. So you're actually dissipating the energy and it's taking a different form, which is heat. So these same types of properties can be applied to electronic sciences. So potential energy, kinetic energy, and dissipation all exist in electronic science as well. So in electronic science, if you have potential energy, it's called capacitance. And what that basically is a potential electric energy stored in a capacitor or a battery. So you have potential energy, just like the spring, ready to be released through capacitance. Simple principle. In electric science, you have something called inductance, which is kinetic energy And an example of kinetic electric energy stored in an inductor would be a magnetic field. So now you're beginning to see how math is relating to every type of these different mechanical sciences, okay, all possessing the same types of energy systems. Okay, so the third in electronic science, relating to dissipation, would be dissipation or transmission. So either you're going to have a resistor or a conductor, which is going to transmit transmission. It's going to transmit either inefficiently if you have a resistor or efficiently if you have a conductor. And that is how your electronic energy or your electric energy dissipates. Okay, so now we see how all these different things relate. All of these things are principles that engineers use to design things. The cornerstone of physics, and the universal language of math used to express and design these systems. So let's get on to economics. Economics, too, is a science of sorts. Some have argued that it's actually a propaganda tool, but not me. I know economics is a real thing, whether it be the economics of efficiency, the economics of money, the law of diminishing returns. I believe that if the right economists are invited into our society, we can actually get positive net gain on our investments, and we can all grow as a species. But let me show you here how economics also uses these energy systems, just like physical mechanics or electronic science. So in economics, to have economic capacitance, or capacitance, I'm not exactly sure how you say that. That's what happens when you read more than you hear people speak. But that's essentially the potential energy stored, or your potential energy, yes, stored in your economic system. Okay, and that is your capital, which would be your money, your stock, stock being inventory, not being like paper stock, paper contracts, investments in durables, etc., etc., etc. You know, physical capital, or a unit of exchange that you can use to trade for a physical durable good. Now that's the potential energy, and let me be clear here. The next point is economic conductance, or also known as the kinetic energy of your economic system. And these are your goods, okay? Your production flow coefficients, your production flow coefficients. So, okay, economic conductance, aka your kinetic energy. All right, let's use this as a quick example. They weren't, because of the debt situation here in the United States, you had a situation where people couldn't borrow money to buy cars. So what they did to make the production numbers appear high, basically to fudge the numbers and make the economy look good, is they took inventories off the lots and basically moved them, and they just sit out in the desert and rot and rust. They basically produce all of this useless stuff because there's no demand for it in order to have kinetic energy in the system. Well, if the system is not functioning properly, or your money supply is not moving, you don't have any money velocity, then your goods are going to sit and they're going to rust because they can't move, because the kinetic energy is not there in your economic system. Okay. All right, let's see. Let's get down to 3C here. Now, here's the most important part, and the part that's going to lead on to other things that's going to relate basically to mind control. Economic inductance. Okay, so economic inductance relates to dissipation. So what is economic inductance? It's services, or basically the influence of the population on output. So it's how the people are interacting with the monetary system. It's how the friction is released, how the pressure is released, the psychology of the people. It is everything that has to do with the influence of the population on output, how they feel, what their confidence is in the monetary system. Just like you would have a resistor or a conductor, economic inductance is the same thing. Is it being transmitted easily along a line that is a really good conductor, or is there a lot of resistance to it? Economic induction is influenced with financial engineering, with the same types of machinery or mathematical models that you would use in physical mechanics or electronic science. Same principles can be applied to economics as well. So if you have something that is efficiently engineered in a physical mechanics sort of way, take for example the Swedes have a new sub, and it's actually a diesel electric sub, kind of World War II technology, but it actually takes an idea from the 1800s, where they used to have these really powerful steam engines for the locomotives, and it would put tremendous pressure on these pressurized tanks, basically, to drive the pistons in the locomotive, and then it would bring movement. So you would have fire, create steam, steam fills the chamber, pushes the piston, and the locomotive moves. Well, it was extremely dangerous. They blew up because at the time they didn't have a good quality enough steel, and when these things exploded, they caused a lot of damage and hurt a lot of people. So one inventor, I forget what his name was, but he came up with an idea that he could basically have tubes off of this pressurized chamber, basically to conserve heat, to keep the heat from bleeding off through the metal, and kind of release the pressure. I know I'm not explaining this very well, but releasing the pressure, not causing as much pressure on the pressurized tank or the steam tank, and basically with the more tubes that came on the outside of it that came down, it conserved the heat. So it was basically keeping kind of a consistent pressure. Well, the Swedes basically have brought this technology back into existence, which creates an ultra-silent sub. But the reason that I mention this is because the engineering is so good, the friction or the resistance in the mechanical energy is managed. It's managed the way that they want it to be. Same thing with electronic science. You have to have certain mechanisms in play to keep your motherboard from overheating, or things of that nature. You want better fiber optic cable that transmits electronic signals easier than old style copper wire. So same thing with economics. You take these other principles and you're able to get an engineered result in your economic induction sort of thing. So it's either going to have greater resistance or more kind of, to borrow a term, conductivity from electronic science. All right, so next point, shock testing. Now, anybody that knows anything about mechanical engineering knows that they do something called shock testing. And a prime example of this would be where they would take a cannon or gun and mount it on an airframe and fire it. Well, we all know that airframes are delicate. I mean, they have to be able to fly through the air. And if you fire a heavy gun off of an airframe, it's going to cause vibrations in the airframe. It could be like the vibration of a guitar string or a tuning fork, or it could rattle the nuts and bolts loose, can rip apart the airframe. So they got to do something called shock testing. So they put the airframe under tremendous stress to find out where the failures are going to be. Okay. Well, the same principles are applied in something called economic shock testing. Okay, so economic shock testing, what happens is they take a commodity like beef or coffee or gasoline or sugar, okay, and they make it, either they shrink the supply or they increase the price of the good, modifying the input in some way. So they're shock testing it. Bam! I think you guys can probably remember back in, like 2004, 2003 or 4, gas was like almost $5 a gallon, $4 a gallon. And you could see all the different ways that it affected or had an effect on the rest of the economy as a whole. So what happens when you do an economic shock test is you're going to have observed outputs. Okay, and observed outputs are measurable quantitative relationships that result in probabilities that are assigned over time. And this is what happens when you can gather large data sets and employ algorithms to analyze those data sets. The more data that you can gather, the more data that you can analyze, and you can assign probabilities for absolutely everything. So a gasoline price rise, the probability that a person experiences a headache changes. The probability that somebody wants to go and watch a violent movie changes. The probability that somebody goes and smokes a cigarette changes. The probability that somebody visits a tavern and has a beer changes. So all these probabilities, the purpose of economic shock testing is to find out the relationships as best they can to assign different probabilities so they can find out how people will react. And in that, you have mind control, basic mind control. So you find out what motivates people, what stimulates people, how far you can push them, what they're going to do. All of it has probability, and all of that probability is interlaced. And, I'll get into input outputs maybe on the next video or the following video so you can understand what the inputs are and what the outputs would be, or desired outcomes could potentially be. And probably in the next video, I'll talk about something called economic amplifiers. So that's how financial engineering kind of breaks down if you look at it from the perspective of any other type of engineering. So it's been Hank. Catch you guys on the flip side.